Very much. Pleasure to be here. So, in 2020, Recycling Victoria launched a 10-year circular economy policy. The policy includes the following reforms that are related to household recycling. Access for all Victorian households to a 4-stream waste and recycling system. So that's food organics and garden organics, or FOGO, separated glass, other commingled recycling, and residual waste. It included the standardisation of kerbside services across all local government authorities, including the colours of each bin lid and the exact items that are included in each bin. And the policy committed to the introduction of the Container Deposit Scheme, or CDS, which was launched in Victoria in November 2023. The Victorian CDS currently accepts certain glass containers, but not wine or spirits bottles. In 2024, the state government published the draft service standards, which outline how this 4-stream waste and recycling service needs to be delivered. The objectives of the service standard are to make recycling simpler, to reduce emissions, to capture a greater value of recyclables so that less raw materials need to be extracted, and to reduce the amount of household waste that goes to landfill. So the implication of these legislative reforms is that by the 1st of July 2027, all LGAs in Victoria will need to comply with the service standards, including the requirement to provide a separate kerbside glass bin. A regulatory impact statement, the RIS, was published in 2024, and the RIS presents a case that Victorian councils will incur an overall reduction in operational costs and disposal costs if the proposed reforms for kerbside glass and FOGO are implemented. TNT was approached last year by a group of 22 councils who wanted to improve their understanding of the impact of the proposed service changes in terms of meeting the needs of their communities, providing value for money, and effectively contributing to both local and national circular economy goals, along with broader sustainability goals. The research and modelling project that we undertook to address these questions included 2 main parts. The first is a research component that sought to gain local and international insights into a number of questions. With limited time today, I can only run through the main questions that we addressed, and I'll include 1 or 2 key insights where that's relevant to the material that I'll be presenting today. We had conversations with material recovery facility and glass beneficiation plant operators, and overall, there was a lot less emphasis on the need for a separated glass stream than we expected. We heard that receiving glass through the commingled recycling stream doesn't impact the ability of these operators to access recycling markets, and that they haven't experienced higher prices for other recyclate, like paper and cardboard, that come from glass-free recycling collections. We looked into the current material flow of recycled glass in Victoria, and also both the current and future capacity for glass recycling in Victoria. We looked at differences in the impact and the outcome from collecting glass in commingled versus separate kerbside bins. So there are various studies looking at how much glass is recovered through both these different options, and also lifetime environmental impacts of glass that's collected through both of these different bins. We looked at the greenhouse gas emissions of recycled glass versus glass that's produced from virgin materials, and also the emissions of recycling glass to glass versus recycling glass into aggregates. We looked at the impact of expanding the CDS acceptance to include wine and spirits bottles in other Australian states. And we looked at the market forces impacting the value and the demand for recycled glass in Victoria. The second part of the project involved collecting information from the participating 22 councils on their current waste operations. The data that we collected included the cost of service provision, including collection, bulk haulage, processing and disposal, material capture, so the quantity and composition of material collected in the existing stream, the in-house resources that were required to deliver the existing waste services, and any emissions data that these councils had relating to their existing kerbside collections. This data was then aggregated to represent a typical council. So it's important to note that this typical council is representative only of the participating councils. It's not an average of all Victorian councils or anything like that. So here's an example of some of the key assumptions and characteristics of this typical council and how they compare to the assumptions in the Regulatory Impact Statement, or the RIS. Again, I don't have time to go through this table in detail, so I'll just give a quick overview. The top 3 rows in the table show the amount of waste in the kerbside bins. And you can see that the RIS assumes more waste is being captured in the general waste bin and considerably less in the commingled recycling bin than what we saw for the typical council. However, overall, the quantity of kerbside waste is really similar for the RIS and for the typical council. Now, the RIS was developed before the Victorian CDS was launched, and it predicted a 17% reduction in the quantity of commingled recycling due to the introduction of the CDS. This was higher than the data from councils, which reflected nearly a year of CDS operation, and that showed an 8% reduction. We used the characteristics of this typical council to model 4 different scenarios for waste collection, which were developed with the aim of understanding how both adding a separate kerbside glass collection and expanding the acceptance criteria of the CDS to include wine and spirits bottles could address the aims of the new regulations. During the research phase of the project, we found evidence to suggest that including wine and spirits bottles in the CDS has improved the overall capture of glass in other Australian states. So this was considered as an option both alongside and instead of a kerbside glass collection. So the 4 scenarios that we modelled for the typical council were the status quo, commingled recycling, and the CDS as it is, the status quo plus a separate kerbside glass collection, option 3, the status quo plus what we're calling an optimised CDS, so accepting wine and spirits bottles through the CDS, and all 4. So a separate glass-side collection at the kerbside and also an optimised CDS. These scenarios were all modelled based on the typical council inputs. Additionally, a 5th outcome was modelled, which used the assumptions that were presented in the RIS. And it's important to remember in the following slides that the results that are shown as RIS results aren't results that were presented in the RIS, but the results of the model that we ran using the assumptions that were presented in the RIS. The first output that I'd like to share is the cost of providing the collection services. So on this graph, the y-axis shows the net cost of providing each of the modelled scenarios for the typical council per property. The cost is for delivering all of the kerbside services, so collection, processing and disposal of glass, commingled recycling, general waste and FOGO. The cost includes both operational costs and also an annualised implementation cost. And along the x-axis, you can see the 4 scenarios that we modelled, plus the model being run on the assumptions set out in the RIS. You can see that the net costs for providing a separate glass service, so that's options 2 and 4, are higher than the 2 options without separated glass, and they're also higher than the RIS model. However, it's really important to note that there's only a $36 difference between the highest and the lowest net cost. And as you can see from the error bars, there isn't a significant difference between any of the options or the RIS option. We use sensitivity settings to test some of the assumptions of the model outputs, and collection costs, which include the purchase of bins, were found to be the greatest proportion of the cost for the options that include a separate glass collection. Options 2, 3 and 4 all included savings on disposal costs compared to the status quo due to a modelled reduction of glass winding up in the general waste bin. And for options 3 and 4, the increased capture of glass through the CDS also resulted in a small cost offset through increased CDS revenue for councils. However, that was really minor in the scale of the costs. This graph shows the modelled cost and modelled gross cost of providing the waste collection. Again, we've got total annual cost on the y-axis, but this time it's the total cost for the typical council rather than broken down per property. The cost of providing a FOGO service, which is shown in green, is consistent across all 4 modelled scenarios, and there's only a very slight variation in the cost of the general waste service, shown in red. The commingled recycling service, shown in yellow, decreases slightly where a separate glass collection is offered. However, this decrease is vastly offset by the costs of the glass service, which you can see shown in purple. And then the cost for implementing the separate glass service are those tiny grey bars at the top. When you look at just the commingled recycling and glass costs, there's a notable difference between the costs modelled from the typical council data and those modelled from the RIS assumptions. So if we zoom in on just the commingled and glass options from the outputs from the RIS and from option 2, which is the service option that's equivalent to what was presented in the RIS, we can see the scale of that difference. So the difference between these two outputs suggests that the cost of delivering recycling services has increased markedly since the RIS was developed. Additionally, the RIS assumes a much lower implementation costs for councils than the data that we collected from the council suggests. So implementation costs include bin purchase and delivery, project management that's associated with delivering a glass service, procurement and contract negotiation, planning, education and administration. The RIS assumes that councils will receive funding that will cover a significant portion of these implementation costs, which is why the RIS cost is much smaller. Funding wasn't factored into the typical council model, and overall, as you can see, the implementation costs aren't really a significant driver of the cost differences. Aside from cost, the other main consideration for the model was material recovery. This graph shows the annual tonnes of material covered across the 4 scenarios and based on the RIS assumptions. Again, commingled recycling is shown in yellow, glass collected from the kerbside glass bin is shown in purple, collected just from the kerbside is shown in purple, and glass collected from the CDS is in blue. The quantity of commingled recycling is consistent across all 4 scenarios, with a separate kerbside glass collection slightly increasing the amount of glass captured, so it's the purple, in options 2 and 4. Expanding the CDS in options 3 and 4 diverts some glass away from kerbside collections, but overall the quantity of glass that's collected is similar to that in scenarios 1 and 2, which model the current CDS. Overall, there's a very minor difference in material recovery between the different scenarios, suggesting that changes to the kerbside service may not result in a significant improvement in material capture. You'll have seen that there's a notable difference between the amount of material recovered between the assumptions in the RIS and the recent data provided by council. This difference is likely to be due to differences in how the waste generation data was derived. For example, it isn't clear whether the RIS accounts for all waste that's available in each stream, or just the waste that's sorted into the correct bin. We used sensitivity settings to consider the impact of waste generation and material capture on the material that's recovered. And we found that higher rates of material capture, so a system that's already collecting a really high quantity of material, saw less benefit in introducing a separate glass collection. This suggests that councils with a low rate of material capture now may have the most to gain from introducing a separate glass service in terms of glass capture. And the last aspect of the service that the model considered was carbon emissions. Emission sources that were considered included both the additional emissions from running a separate glass kerbside collection and reduced carbon emissions related to increased glass recycling, reducing the need to extract raw materials. From our conversations with industry during the research phase of the project, we heard that a significant portion of glass is already recycled glass to glass, and based on this, the model assumes that emissions reductions only apply to glass that's captured in each of the new glass that's captured in each of the scenarios, so not to glass that's already been captured through the CDS or the commingled recycling bin. Race through this, I heard the bell. So this is a high-level emissions assessment that shows all 3 modelled scenarios in terms of the overall net benefit, so reduction in carbon emissions, compared to the status quo. Both options 2 and 4 have a net reduction in CO2 equivalent of around 300 tonnes a year, which is roughly equivalent to the annual carbon emissions of about 24 Victorian residents. So the additional capture of glass and benefits of recycling that glass over extracting raw materials outweigh the emissions from the additional trucks needed to collect the glass in the first place. And you can see that the optimised CDS without a separate glass collection also has shows a net benefit, but it's a lot lower than the other options. To wrap up, overall, the research and modelling provides some evidence to suggest that separated glass collections might be beneficial for accessing glass-to-glass recycling and for carbon emissions. However, it's not straightforward. The costs and benefits of a separate glass collection depend on a range of factors that will be different for each council, and the real-world impact will depend on education, community behaviour, the efficiency of recycling collection, and the efficiency of downstream processing. Our modelling didn't identify a significant difference between costs per property for any of the scenarios that we modelled using the typical council data, and we weren't able to replicate the overall net financial benefit for implementing a separate kerbside glass collection that was presented in the RIS. The councils that we were working for on this project wanted to better understand how the proposed changes would meet their community's needs, provide value for money, and contribute to circular economy and sustainability goals. Overall, we found that these costs and benefits vary from council to council and are really impacted by the values and the key drivers of each different community. Our typical council model provides a useful framework that we've subsequently been able to use to drill down into the costs and benefits for individual councils, tailoring the model to each council's specific context and helping each council to develop their plans for these upcoming service changes. That's the end.